Okay, we're going to continue our discussion of section 7.7, which is the application of linear equations. So again, we are trying to find two equations that we can solve with either elimination or substitution. So the first problem is John wants to make 100 milliliters of a 5% alcohol solution. So this is what he wants to make. This is the total. He's going to mix some quantity of a 2% with some quantity of a 7% solution. He's trying to find how much of each of those two solutions that he must use. So the total amount that he wants to make is 100 milliliters of a 5%, and we need to change that to a decimal. And again, the amount times the percent of the solution equals our total. So now let's look at the quantity. We don't know how much of the 2%, so let's let that be our first mixture. So we don't know how much, but we know it's 0.02. If I multiply that together, I'm going to get 2% times how much ever I have. And then the quantity of the second one, we don't know. So let's let that be y. And we know it's 7%. So if we multiply that together, and I'm going to multiply this together, which should give me 5. My two equations are here. Here's one of them. Here is the other one. Okay, so if I take x plus y, I should get 100 milliliters. Now what we're doing is kind of applying the cost, or the percentage. So 0.02x plus, we're adding these two together to get 5. 0.07x, this is not cost, it's percentage, equals 5. And again, we can solve those two equations either way. I'm going to use substitution because these are both 1. So I'm going to change this one and subtract x from both sides. So y equals 100 minus x, and then I'm going to plug that in for y. Before I do that though, I'm going to clear the decimals here just so it'll be a little bit easier. So I'm going to multiply everything by 100. So this is 2x plus 7x equals 500. We have to be careful. So here are our two equations basically. So now we're going to substitute in y. Why do I keep changing that to an x? I don't know. So I'm going to plug in y into y. So 2x plus 7, 100 minus x equals 500. Distribute, combine like terms. I'm going to get negative 5x plus 700 equals 500. Subtract 700 from both sides gives me negative 5x equals negative 200. And x equals 40. So I have 40 milliliters of, this was x, 2%. And now I need to find y. So if I know that my total was 100 and 40 of it was x, y has to be 60 milliliters of a 7% solution. Okay, let's look at another mixture problem. How many liters each of 15 and 33? So I don't know how much of these are in each one, but it's going to mix it to obtain this as my total. So I'm going to mix the 15 plus the 33, and I need to know the amounts. So I'm going to let this one be X amount and this one be Y. So my first mixture is the 15%. Well, I don't know how much, but I know that percentage is 0.15. That's 0.15X. My second mixture, I don't know how much, but I know it's a 33%, and if I multiply that together, and my total should be 120 liters at a 0.21, and if I multiply these two together, I get 25.2. So again, my two equations are here. So X plus Y equals 120, and the other one is 0.15X plus 0.3Y equals 25.2. I'm adding X plus Y to get the total. This mixture plus this mixture equals that mixture. And in this one I chose not to clear the decimals. You can do this however you like. Again, I'm going to use substitution. So I'm going to subtract X from both sides, 120. Let's just change that up a little bit. Y equals 120 minus X, and then I'm going to substitute that in for Y. And it probably would have been easier if I would change the decimal here, but that's okay. I'm going to do one different. So 0.15X plus 0.33, 120 minus X equals 25.2. Distribute, combine like terms. 0.33 times 120 is 39.6. Distribute this would be a negative 0.33X. I'm going to combine like terms, these two here. This is a minus, so I should be getting a negative 0.18X plus 39.6 equals 25.2. Subtract this, I get negative 0.18X equals negative 14.4. Divide by negative 0.18, and X equals 80 liters. That was my X. It's a 15% solution. I have 1. I need the Y. Well, if I know that my total was 120 and part of it is 80, I know that the other is 40. So Y equals 40 liters, and the Y was 33% solution. All right, last problem. This is a distance and rate problem. A little confusing, but I think once you get it, we'll be okay. So when we look at distance and rate, or motion problems, the formula is distance equals rate times time, or shortcut, distance equals rate times time. So rate times time equals distance. Okay, so we've got a boat that's gone downstream and upstream. A boat traveled 210 miles downstream and back. So we went down 210 miles and he went up 210 miles. So the distance on both is 210. The trip downstream took 10 hours. That is our time. The trip back took 70 hours. Well, of course, you're going to go downstream faster than you are going to go upstream because you've got the current against you when you go upstream. So it took them a whole lot more hours to go upstream. I don't know what the rate is, so let's let R be the rate. What is the speed of the boat in still water? So if there was no current, this is actually our rate. And we need to find the speed or the rate of the current, because the current's going to affect how fast the boat can go. So let's let C be our current. When we look at downstream, we've got the rate of the boat, and the current affects it going down and up. When you go downstream, the current helps you or gives you more speed, so the current is going to help it. Going upstream, you've got the rate of the boat, and the stream is pulling against you or making you go slower. So now I have my two equations. R plus C, we can look at it like that, times 10 equals 210. R minus C times 70 equals 210. So I have 10 times R plus C equals 210. And I have 70 times R minus C equals 210. So there's a couple ways that I can do this. I see that both of these equal 210. I could let this equal this. That's one way I could do it, because they both equal the same thing. I'm going to make this one, though, I'm going to do it a little different. I'm going to divide this by 10, this one by 70. So now I have R plus C equals 21, and I have R minus C equals 3. So here are my two equations. If I add them together, a little bit more room here. R plus C equals 21 and R minus C equals 3. You can see that these are opposite signs, so I'm good. So these cancel out. I get R plus R is 2R. 21 plus 3 is 24. The rate of the boat is 12. 12 miles per hour is the boat speed. But the question asked us for the current. Well, if I know if the boat speed is 12 minus what is going to give me 3, the current is 9 miles per hour. And I can do it here too. 12 plus what equals 21. Or I could plug back into the original equation. Okay, that's end of chapter 7.7.